Good morning children, welcome back to physics class. Today we will continue with the chapter dimensional analysis. Let us revise the definition of dimensions. So the dimensions can be defined as, you all know the definition, dimensions are the powers to which fundamental physical quantities are raised. Dimensions are the powers to which fundamental physical quantities are raised to obtain derived units. So the prime use of dimension is, you have to use the formula of the physical quantity and then you need to derive units of that physical quantity. I have discussed about certain physical quantity which you have already learned in class 9th and 10th. So what are the denotions of these physical quantities? There are 5 physical quantities, fundamental physical quantities, which are to be used in dimensions. I am mentioning it again. That is mass. Mass is denoted in dimensions as capital M. Length we will use as capital L. Then temperature, in the case of temperature we have to use SI unit Kelvin or we can use theta. This is the denotation for temperature in dimensional analysis. Then there is time. For time we will use capital T, and the last one is current. For current we will use its SI unit, that is ampere, and denotation will be capital A. All will be in square brackets. So these 5 fundamental quantities are to be used in dimensions. I have discussed and derived the units by using dimensional analysis of certain physical quantities. Now continuing with that, I am taking certain physical quantity which you have not learned in the previous class. Now that is surface tension. This is example of surface tension. Surface tension is, you must know what is the formula for surface tension. Surface tension is force acting per unit length. Force acting per unit length. This is found in fluids. Force, you all know what is the dimension of force, ml t minus 2. We have discussed this in previous class. Length is capital L. So this becomes mt minus 2. This is the dimension of surface tension, and from this dimension you know the power of mass is 1 and power of time is minus 2. So this is dimension, and what is its unit? Unit will become kilogram per second square. This is unit which we have derived from dimension. So this is known as dimensional formula for surface tension. Similarly, next example is angular momentum. What is angular momentum? Angular momentum is in rotational motion or circular motion, that is moment of linear momentum. It is given by r into p. P is linear momentum, r is distance from axis of rotation. So r is length and momentum is mass into velocity, that is ml t minus 1. So mass into velocity is ml t minus 1. So this becomes ml square t minus 1. This is the dimensional formula for angular momentum. And what will be the unit? Unit is kilogram meter square per second. This is the unit. Similarly, coefficient of viscosity is another physical quantity. Coefficient of viscosity, it is denoted by eta. Coefficient of viscosity, you must know the formula. This is force upon area into velocity gradient. What is velocity gradient? So, velocity gradient is change in velocity with respect to distance. So, you need to find the dimension of coefficient of viscosity. Force, dimension of force is ml t minus 2. Dimension of area is L square. Dimension of area is L square, and velocity gradient, that is Lt minus 1, that is change in velocity, Lt minus 1 divided by R, that is L. So, now the dimension of coefficient of viscosity will be mlt minus 2, and this L and L cancel out. So, this is L minus 2 T. On solving it, you are getting ml minus 1 and T minus 1. This is the dimensional formula for coefficient of viscosity. This is the dimensional formula for coefficient of viscosity, and unit will be kilogram per meter per second. So, these are certain physical quantities which you have not studied in the previous class. These are the physical quantities which you have not studied in previous class. We will discuss some more physical quantities in the next video.